Good morning, everyone. Hope all is well. Hope everyone's doing all right. We have a few still trying to get in, so we'll let them do so, and then we'll get started. All right. Looks like everybody is, got one person still trying to connect. I think we'll be all right. So, good morning. Hope all is well. Hope everyone's doing all right. Hope you had a great weekend, great spring break. Appreciate those who actually tuned in for the Pi Day. Pi Day. So we had a good time. We had a good time. So you see 7.1. We have some definitions. If I were to go to Math Lab, where is it? So got a definition right here, just like we did for chapter 1 and chapter 2. So just 16 of them. So that's chapter 1. I mean, chapter 1, section 1 out of chapter 7. So there will not be a lecture for that. Just, take care of these definitions, shoot them to me as soon as possible. All right. So we'll just do 7.2 today. And like I said, 7.1 is covered in those definitions. All right. So looking at 7.2, measuring of the survey. So statisticians evaluate the method using for a survey, not the outcome of a single survey because of bias. All right, statistics vary from sample to sample. Says no matter how many different samples we take, the value of P, which is your population proportion, is always the same. But the value of P hat, which is your sample proportion, changes. Everybody done with the black? Scroll up a little bit. There we go. So P hat will change from sample to sample. So when you talk about your population is your population. So that's not going to change. If your population likes something at 20%, it don't matter how many samples you take and test those, your population will stay the population. So that's all it's stating here. But every time you take a sample out and you measure the sample or do a survey on the sample, that's going to change because you're taking a different sample. If you're taking 5 people from Virginia, then you take 5 people from California, and you're taking 5 people from New York, all of them are samples out of the United States. And so, those samples may change according to the people you've chosen. All right, can we scroll up? All right, so just an example of that. We have 25% of the population are cat people. In other words, cat people are people who love cats. This population is not going to change. If 25% of the people love cats, then 25% of the people love cats. But when I take my first sample, when I do a survey on them, 25% of them may love cats. But then when I take my second sample, 50% of them could love cats, love cats. Then when I take my third sample and do a survey on them, maybe 0% of them love cats. So that's what we're talking about when you start taking your samples. The sample population or the sample survey could produce something different each time, but the population will always stay the same because that's just pulling from the grand population of the survey of the population. All right. Questions, questions, questions. And then once again, P is your population proportion. P hat will be your sample. Let's emphasize here as well. So probability distribution of P hat has a special name. It's called your sampling distribution. It is a statistic we use to estimate the population parameter. Bias is measured using the center of the sampling distribution. It is the distance between the center and the population value. I scroll up on red. So precision is measured using the standard deviation of the sampling distribution, which is called your standard error, SE for short. And the last green statement, when the standard error is small, we say the estimator is precise. Something real quick, sorry about that. Okay. Trying to see why I got 2, 3, where's my 1 at? There we go, okay. Yeah, so we labeling these facts right here. So that's 1. And now we're at 2. So the size of the population does not affect the precision. Precision of an estimator does not depend on the size of the population. It depends on the sample size. So these are things that MATLAB may ask you and may emphasize throughout the session or throughout the assignment. So that's one of the reasons why I pointed these out for you, and things that'll help you with your foundation as you go about doing your calculations. So an estimator based on a sample size of 10 is just as precise in a population of 1,000 people as in a population of 1 million. So it's the sample size you want to increase if you want to increase your precision. And that's what we'll get into the third statement.
I was about to ask, can you scroll up just a little bit to the word million? So yeah, you can scroll down a little bit, just so I can see the top of the paragraph of number 2.
Oh, number 2. Okay. Is that good?
Mm-hmm.
Okay.
Thank you.
Yeah, no problem. All right. If I scroll up too far, let me know. So 3 large samples produce more precise estimators. Everybody holding on to the purple. Okay, what we should know from a sample size of 100 people says the estimator p hat is unbiased for all sample sizes as long as we take a random sample. As long as we're taking random samples, it is considered unbiased. The precision improves as the sample size gets larger. And I'll pause right there, give you guys a chance to write. Oh, is that it? Nope. So wait a second. Then that last statement in green, the shape of the sampling distribution is more symmetric for larger sample sizes. All right, surveys based on larger sample sizes have smaller standard errors and therefore better precision. All right. So finding the bias and standard error. Bias and standard errors are easy to find for a sample proportion under certain conditions. So the bias of the sample proportion p hat is 0, and the standard error is, if I done with that dark blue, All right. So we'll be able to calculate our standard error by taking the square root of p times 1 minus p over n. And that stands if the following conditions are met. So I'll give you a chance to write this down before we scroll up. All right. So condition 1, sample must be randomly selected from the population of interest, either with or without replacement. If the sampling is without replacement, the population needs to be larger than the sample size, much larger, excuse me, than the sample size, at least 10 times bigger. All right, can you scroll up? Of course, let me know if I'm going up too far. Okay, so looking at example, we're looking at pet world. Suppose that in pet world, the population is 1,000 people and 25% of the people or 25% of the population are cat people. Cat people love cats, but hate dogs. Let me write that a little better. So you're a cat person in this pet world, in this scenario, it's not that you just love cats, but you love cats and hate dogs. So we are planning a survey in which we take a random sample of 100 people without replacement. And I give you a chance to write it down before I scroll up. Too far. Is everybody done with the red? Okay. What value should we expect for our sample proportion? All right. What's the standard error? And then how do we interpret these values? All right, everybody good before we go into question A?
I'm still copying the block.
All right, do I need to move it or scroll or anything, or you just copying from where we are?
Just copying from where we are.
Okay, we'll pause for a second, just make sure you're good.
Okay, I'm done.
All right, all right. So looking at A, what value should we expect for the sample proportion? So the sample proportion is unbiased. So we should expect it, or we would expect it to be 25%, the same as the population. So we're not talking about what it would actually be, but what should we expect it to be is the same as the population. But of course, we already showed how it is possible for it to be different, and it is possible for your sample to be different each time depending on who you chose. You survey them, you may choose all dog people. You chose 5 people and just so happened that all 5 of them ended up being dog people. Then of course it wouldn't be 25% because they are dog people, not cat people. All right. So then it says, what's the standard error? And so we're going to lean on the calculation of our standard error formula. P is the population proportion. P is 25%. We got that from the problem. All right. So that'll be the square root of 0.25 times 1 minus 0.25 over 100. Do that calculation, and it ends up giving us 0.0433 or 4.33%. So MathLab will let you know whether they want the answer in percentage or decimal. Any problem before we go to C? So the interpretation. So if you take a sample of 100 people, then we expect 25% of them to be cat people, give or take that 4.33%. That standard error is our give, plus or minus that percentage. All right, any questions, any questions? All right. So, okay, so that's the end of 7.2. So we're gonna pause right here. Remember I said all I was gonna do is 7.2 today because 7.1 is part of today's stuff. It's just that, you have your definitions to go take care of. And, there's no rush to, try to run through chapter 7. So next class, we'll get into 7.3 and I'll move ahead accordingly. But before we close out today, questions on anything. Make sure we're good. All right. So we're going to come back to pet world and cat people and a few more examples, but we're going to add a little more to it, jumping into 7.3. But if you guys are good, I'm good. Have a great weekend. Be safe. Like I said, get those 7.1 definitions knocked out. Shoot them to me as soon as possible. And then we'll go from there. All right. So if you guys are good, I'm good. Take care. Have any questions for me, feel free to stay back. All right. Take care. All right. Thank you. Thank you. All right. Everybody have a good one.